into expression of a complex number in a rectangular form. In rectangular form. So expression of a complex number in rectangular form. So we'll have z is equals to a plus b times j. So sometimes this can be rearranged and have j times b, but we'll have a number there. So I want to draw out some notes. Let's hope my paper doesn't shift. So there's something that you need to know um, when it comes to this value here, a, and the other one, or the part which consists of the second part, the second term. So the second part, so the first part, this is the real part. So that is the real part, and this is the imaginary part. Imaginary. So that is the imaginary part. So we say it's an imaginary part because at this section here, a here it will be a real value, and this one it consists of let's say j, which is a non-real number. So in here that we have a real part and imaginary part, we will understand it that way. So we have its Cartesian plane. We have its Cartesian plane. So you can have you can plot on an Argand diagram. We call this an Argand diagram. Argand. So I'll remember the spelling when I remember. So an Argand diagram. So Argand diagram. Let me erase them. So we will have an Argand diagram plotting the complex number there. So this will be the j-axis. This will be the real axis or real part axis. So real axis, where we plot the real part. So in that case, let's assume that a, it is a positive value. So we are going to plot on the positive side, similarly like the x and y axis that you know. For real a and the x axis, we plot the real part, the real values. On the y axis, we plot the imaginary values, more especially the coefficient of j. So let's say we move, this will be a unit to the right, and let's say j here, b here, that will be b. It's the coefficient of j, the imaginary part. So it gives us the value there. So when you join them, at that point when you join them, you'll subtend the line to the point O, point 0. So therefore, here we'll have angle theta. Angle theta, it's formed. Angle theta, it's formed. Try and enlarge it. So angle theta is formed there. Let me just do some errors. So I have angle theta then. So angle theta. So I have angle theta. So we always know that we'll plot in this type of Argand diagram. When they say plot the complex number, we'll plot it in that way. So you need to know how do we find B, for an example, before we go to polar form. Did I say B? I want to say R. So if you find R, which we call it modulus, it will be a square root of B squared plus A squared. So we say this is a modulus. This is a modulus. And we need to know that how do you find our argument theta. So theta will always be equals to tan arctan. Let me say arctan B over A. So we'll have arctan B over A. So this will help us to find, for an example, let's say theta. But now if let's say we wanted to find the modulus R when we're converting to polar form where we're going, we will have to find R and find theta. So there's notes that I want to put, the notes that I want to put for theta. For theta. So for theta, so for an example, if let's say, if let's say we have negative B, let's say for example, it is B which is negative. Yeah, let's say if B is negative, therefore theta will be equals to. So if it's B which is negative, therefore theta will be equals to. We are going to say 360 minus arctan, the positive ratio, arctan B over A, arctan B over A. If you see that when you are looking for, let's say you're saying tan is equals to negative B over A, and B is the one which is negative, the solution must be in the fourth quadrant to say 360 minus. If let's say for an example, if now it's A which is negative, let's say you have B over negative A. Though the ratio is negative, but the solution, just note that therefore theta will be equals to. So this will be in the third quadrant, where you say it will be 180, 180. In the third quadrant, 180. Let me use plus. It will be at 180 plus arctan B over A. B over A. So for theta, it will be in the third quadrant. So if let's say, for example, both, okay, made a mistake here. If A was negative and B is positive, so please make sure it's a 180 minus. I see I'm explaining. So it's a minus there. It must be 180 minus. It's in the second quadrant. But when you plot, you'll see it will guide you. It will guide you. But if let's say if both ratios are negative, so this it's either when it's in both, if they are both positive, this is always in the first quadrant. The ratio is always in the first quadrant because we projected in the first quadrant. But if let's say both are negative, therefore theta is equals to 180 plus arctan B over A. If let's say we see that both ratios are not ratios, both values of B and A are negative. So we plot in the third quadrant where tan is positive, because this will give you positive value. So tan will be positive here. So or it's positive here initially. So it's either here and here, tan is positive here. But where it's negative is in the fourth quadrant and the second quadrant. At 180 minus and at 360 minus, that's why it's negative. But we're going there, but always when you solve complex numbers, always plot. So I just want to take a basic one. Just may remove this. So let's see where we're going with that. So if let's say we want to now either plot on an Argand diagram and solve a complex number. Okay, I'm getting one example here. So let's say maybe I can take this and say number one. Let's say I have complex number z in rectangular form. Then we have 5 plus let's say 2j. So we have that. So if let's say we want to plot it on an Argand diagram, we go and plot, therefore we'll have it in that way. So just maybe try and say 1 unit, 2 units, 3 units. So for example, the real part, I'll say 1, 2, 3, and 4, 5. So going up 1, 2, this one, this is 1, 2, 1, 2, 3, 4. So let's say maybe the real part, which is 5, the real part, which is 5. So real part, which is 5 there. So we plot, let me put even the notation there. So it's a real axis. This is a j axis. So I have j axis. So 5 units to the right, 1, 2, 3, 4, 5. And then 2 units up because it's positive, 1, 2. So therefore, a horizontal line, a vertical line where they bisect, you'll have a point, the coordinate there of your A and B. Subtend a line to point O, and we'll have angle theta there. We'll have angle theta. So please represent, maybe we can say 5 and then say 2. So you have represented a complex number on an Argand diagram. But making sure that you have theta there, how will we get theta? We know that check into the solution. Before you do anything, just say B over A. When you say B over A, B is the coefficient of J, which is 2. And A, it is 5. I hope you see B over A is positive. So which means the solutional radius in the first quadrant is tan is positive there. So it will be theta equals to arctan B over A according to the formula. So the B is the coefficient of J, A is the real part. So the answer will be equals to, so arctan 2 over 5, it's 20, 31, okay, it's 21, comma, 8, 0. So it is in degrees, so 21.80 degrees. So I hope you see this value is true there. It's very small, it's even smaller than 30 degrees, not even going to 45. So according to how we plotted this. So we know that, oh, the value, the